Hey folks, so we're going to be talking about graphing polynomial functions today, and we're actually going to be covering a lot of different topics in order to do this effectively. So I'm breaking this video up around 6 slides per video. So the first thing that we want to talk about before we go into actually graphing functions is just going back to basics, right? So let's say that we're given a function f of x, right? So at its most fundamental definition, we want to look specifically at the intercepts, right? So the x-intercept of a function are the x values, so here x values, when f of x equals 0, right? So you can set your function equal to 0 and then solve for your x values in order to figure out your x-intercepts. That makes sense, right? That's how we've been solving for the solutions or roots or zeros of our functions up to this point. For the y-intercepts of a function, they're actually going to be the y values when x equals 0. So in order to figure out what your y-intercept is, you can just substitute all your x's for 0, evaluate your function where x equals 0, and then figure out your y value. And then I don't know why I put this as plural. It should just be 1, right? You can only have one y-intercept, or else it's not going to be a function. So how can you find your intercepts? So you can use good old-fashioned graphing, which we'll talk about later on, or you can use the definition of these intercepts and solve for your intercept. So let's actually find some intercepts, right? So given the function f of x equals negative x to the third power plus 4x, let's find the x and y intercepts. So if I'm finding the x-intercepts, right, I am finding the x value for when my f of x equals 0. So I'm going to take this function over here. Instead of writing f of x, I'm going to substitute in 0 instead. So I have 0 equals negative x to the third power plus 4x. All right, and here's what I want to do. I want to just factor this because I see that it has a common term x, and I know that I can factor that out. So I'm going to actually take out negative x because I don't like when I have a negative coefficient in front of my leading coefficient. Okay, so I have negative x out here, so I'm left with x squared minus 4. Okay, fun for us, we can actually factor this out. This is a difference of squares. We have, negative x, parentheses x plus 2 and x minus 2, right? It's really important that we know how to factor because this is important in finding intercepts. Okay, so now that I have this fully factored out, this is equal to 0, I can now use my zero product property in order to find my x-intercepts, right? So I'm going to set each of these factors equal to 0. So I'm saying negative x equal to 0, x plus 2 equal to 0, and x minus 2 equal to 0. So when I solve for x in each of these equations, I get x equals 0, right? X plus 2 equals 0, I get x equals negative 2. And then x minus 2 equals 0, I get x equals positive 2. And so I know my function is going to pass through or hit the x-axis at these three x values. Let's think about y-intercepts, right? So like we said before, to find our y-intercept, we want to evaluate our function at f of 0, right? So this is the same as f of 0. And so every time I see an x, I'm just going to substitute in a 0. I'm just going to do direct substitution instead of like synthetic substitution. So this is negative 0 to the third power plus 4 times 0. Okay, well, this just evaluates to 0. Right? So my y-intercept is going to be at 0. So this is going to be 0, 0. So at the origin, right, 0, 0, this is going to be my y-intercept. And like I said before, I don't know why I made these at like 2 in the morning. So y-intercept, it should be just y-intercept, not y-intercepts, because if you have more than one y-intercept, then you don't have a function. All right, so we can clearly see where our intercepts are on a graph, which is part of the reason why we do graphing, just because it's a visual representation of this instead of us having to do all this like algebra and stuff, right? So when I'm looking at this function right over here, right, I see that I cross my x-axis at these points, right? So whenever I cross my x-axis, that's going to be my x-intercept, right? You're intercepting the x-axis. So right over here, and right over here. Let's figure out what those actual x values are. So I see my first one furthest to the left, right? This is negative 1, negative 2, negative 3. Okay, so x equals negative 3. That's my first x-intercept. my next x-intercept is going to be 1, 2, so x equals positive 2. And then my last one is at x equals 5. All right, done. We found out our x-intercepts. It's pretty easy when we have a graph, right? If I'm thinking about my y-intercept, right, it's going to be whenever my curve passes through my y-axis, right? It intercepts my y-axis, right? So when I'm looking at my y-axis going up and down, I see that it intercepts right over here. And I'm just looking at the scale over here. I'm noticing each unit is going up by 10. So this is going to be 10, 20, 30. So my y-intercept is going to be y equals 30. Done. And then, all right, so we got some practice problems over here. Take a minute and pause the video. Try out these two practice problems. So you're given a function, you want to find the x and y intercepts, and when you're ready, unpause and let's go over our responses. All right, ready to check your responses? Let's do this together, right? So when we're finding our x-intercepts over here, right? So I'm going to set f of x equals 0. So f of x equal to 0. And so then I get x to the 4th minus 5x squared plus 4 equals 0, right? I noticed that I have my degree as 4, right? And then I see my second highest degree is 2, right? So because 2 is half of 4, I'm going to just try to factor this like a regular quadratic, but instead of in each binomial, it's a linear binomial, it's going to be a quadratic binomial. So let's try that out. Okay, so I'm going to set this equal to 0, right? I have x squared, because I know x squared times x squared equals x to the 4th. And then I know that my constant terms have to multiply to positive 4, but then they should add up to negative 5, right? So I'm going to choose negative 4 and negative 1, right? And when I look at each of these quadratics, I see that I can actually probably break them down even more into their linear binomials. So x squared minus 4, I can factor that as x plus 2 times x minus 2. And then x squared minus 1, I can factor that as x plus 1, x minus 1, difference of squares, right? And then I can just do my zero product property and actually just solve for x now, right? So if I do that, then I know that I have x equals positive 2 and its conjugate, so x equals plus or minus 2. And then I also have x equals 1 and its conjugate, negative 1. And so these are going to be my x-intercepts. For my y-intercept, right, I just need to evaluate at 0. So I'm going to do f of 0. And then once again, I'm just going to do direct substitution. So I have 0 to the 4th minus 5, 0 squared plus 4. And so this is going to be just 4, right? So f of 0, or your y-intercept, is just going to be 4. Let's try out this next one, right? So I have f of x equals x to the 5th minus x. And so to find my x-intercept, I'm just going to set f of x equal to 0, solve for x, right? So, oops, let me just erase that. So I have x to the 5th minus x equal to 0. I'm going to factor out the x. I'm pretty sure I'm going to get a 4th degree polynomial. I can factor out, and I do, right? So I'm going to just kind of treat it like the quadratic, but make each binomial a quadratic binomial instead of a linear binomial. So this is going to be x squared plus 1, and then x squared minus 1 equal to 0. Okay, so I get some complex solutions here, right? Because x squared plus 1 doesn't yield any real solutions. Because we're graphing on an xy plane, we're graphing inherently on a real plane, like a real number plane. So I'm not actually going to include the complex solutions within this function when I'm listing my x-intercepts, right? Because we're not graphing on a complex plane, so I can't graph this complex number that I'm going to get as a solution for this quadratic over here. So I'm only going to include the real solutions that I get in this function. So I get x equals 0. And then if I factor out x squared minus 1 even more, right, I get x and then x squared plus 1, and then x plus 1, oops, and its conjugate. Right, so I also get that x equals 1 and its conjugate, -1. Right, so those are going to be my x-intercepts. My y-intercept, just like before, I'm going to evaluate at 0. So I have f of 0 equals 0 to the 5th power minus 0, and that's just 0, right? So your y-intercept is going to be at 0. All right, so same kind of thing as before, right? We're going to solve for x. So that means that we have to set f of x equal to 0 in order to find our x-intercept. So this is going to be 0 equals x to the third minus 25x, right, in order to find our x-intercept. And then I see that I have a common term x, so I'm going to factor that out. X squared minus 25 equals 0. And then I get a difference of squares over here, right? So I can pretty neatly factor that. So that's x times x plus 5 times x minus 5 equals 0. Great. And then I can just use zero product property in order to figure out what my solutions are, right? So I got x equals 0 and x equals, because I have x plus 5 and its conjugate, my solutions are going to be 5 and its conjugate, -5. All right, so those are my x-intercepts. Let's find our y-intercept. So we can find our y-intercept by evaluating our function at 0. So we have f of 0. That's just going to be 0 to third power minus 25, 0. And then that's just going to be 0. So that's going to be my y-intercept. So let's look at this next one, right? We're given a quadratic now, right? So let's try to see if we can just factor that directly, right? So once again, setting f of x equal to 0, and then solving for x like we normally do. And so this is going to be 0 equals, let me just split this up into two linear binomials. So I have x and x times x equals x squared, so that makes sense. It equals our first term. I'm multiplying to -15, adding up to -2, so that tells me I'm probably going to need to do -5 and +3, right? -5 times +3 multiplies to -15, adds up to -2. Looks like we're in business. And now I can just do zero product property, right? So I can set x plus 3 equal to 0, and I get x equals -3. I can set x minus 5 equal to 0, and then get x equals +5. And these are going to be my x-intercepts. All right, so let's look at my y-intercept. So I'm going to evaluate at 0. So this is 0 squared minus 2 times 0 minus 15. And so this is going to be minus 15, right? Because 0 squared minus 2, 0 is just 0. So that's going to be my f of 0, or my y-intercept. All right, so I'm going to pause the video here, and in the next video, you're going to see the next 6-ish slides of your presentation.